let's quickly hop into these two questions, and these are like really interesting. Before going to any of those two questions, let me tell you, transit is given by 90 minus 500 minus delta, and at culmination this is the highest altitude when it is at the local meridian. Let me tell you an example. Suppose this is just a sphere right here, and let me just make a quick just right there, and let me just quickly make it. Suppose a star is just right here, just going to, it is just revolving around. So let's suppose this is north and this is south, then the transit will be this, the transit. And suppose we are at an altitude of, I don't know, Nepal. We are at Nepal, so it's 28 degree north. So for a northern hemisphere, we know phi is greater than 0. Circumpolar, which is never set, we have condition as 90 minus phi, and for never visible we have phi minus 90. Set visible, right? So a couple of other things, like these are the only thing that you might need. So let's hop into question number 1. We have declination as minus 38 degree. Will the star ever rise above the horizon for an observer at phi equals 28 degree north, Nepal? Let me quickly use the last row too. Sorry for the delay. Okay, we have the question again. Anyways, yeah. So, will it rise for phi equals 28 degree north, right? So we have the never visible. We need to use the never visible condition here, because we just can't directly use always visible one. It might just be a normal star, and that is what we have to check. So declination must be smaller than latitude minus 90 degree. Therefore it is just minus 38 degree is smaller than minus 62 degree. It is false. Therefore the star rises. So we know the maximum altitude transit is given by 90 degree minus phi minus delta. For southern or northern hemisphere we will get 66, because we have declination as negative 24 degree is the maximum altitude. So will the star rise, is it circumpolar for an observer at 40 degrees south? So for an observer at 40 degrees south, we have circumpolarity test for southern hemisphere is this. Just put on the modulus sign. So let's put on 38 degree right here, 9 degree minus 40 degree. Therefore 38 degree is greater than 50 degree, which is again false. Therefore it is not circumpolar. It is just a normal star, because we can check from this that delta declination is greater than 90 minus phi, and 38 degree is greater than or equals to 50. It is the never visible condition for the southern hemisphere, and it was also false. Therefore it must be a normal star. At what latitude does a star just graze the horizon? Just grazes the horizon at upper culmination. That means the H transit. We have this H transit at the culmination, the latitude as 0 degree. Therefore by just this formula, just put in the H transit value right here, phi will come as delta plus 90. Therefore we have minus 38 plus 90 degrees. It will be 52 degrees north. What's the question number D? below what southern latitude does the star become circumpolar? So this is basically the circumpolar condition again, where we have to use the same formula, 90 minus phi. 38 degree to be greater than 90 minus phi, the phi would come as greater than 52 degree. So yeah, the answer would be 52 degrees south below it. Any other questions? One thing about this is that we check the never visible condition for the maximum altitude at the opposite transit. We use the never visible condition. So what if we use the circumpolarity condition into the never visible? I mean, so we have this. Okay, we actually do not have any circumpolar star. For it to be circumpolar star, let's say we are observing from latitude 80 degree. Okay, so 38 degree will of course be greater than 90 minus 80, 38. So this will be a circumpolar star, right? So this will be a circumpolar star. And will circumpolar star also let's equate the phi into here. So 38 degree greater than or equals to 90 minus 80 minus 10. It is greater, means it is, okay, wait, 38 degree must be greater than 90 minus, what was this, 80, right? 80. So 38 degree is greater than or equals to 10 degrees. So it satisfied the, what do we call it, it literally satisfied the not never visible condition, I think. Yeah, so for southern hemisphere, let me quickly make it in here. Never visible condition is, the condition is greater than 90 minus 5, right, for a southern hemisphere. And this right here, let us see the question, is circumpolarity test. So 38 degree is greater than 90 minus phi is just, what do we have it, phi right here, 80, right? So 30, it just satisfies it, while it also does satisfy it. So it comes to about what signs and modulus you use. I think one of this is incorrect. I don't think modulus signs are to be used a lot. Just have your common intuition about what is going on. Let me erase this. So let's hop into another question which we have. What is the minimum altitude? At what minimum does the sun never set on the sun? So the same literal thing, phi must be greater than 90 minus delta, and phi is greater than 6.5 north. At what latitude does the sun transit exactly at zenith? Obviously phi must be equal to delta, because just see this, for it to be overhead, sun is overhead at the summer solstice, right? So for transit we need phi must be equal to delta, because 90 minus phi minus delta, and if they are equal they will be 0. So its transit will be 90 degree. An observer notices the sun setting exactly on the horizon at local midnight. What is their latitude and what azimuth does the sun have at that moment? So since it is local midnight, then we have 12 hours. So let's quickly calculate the phi, which is 66.5 north, right? What is the latitude? We got this. What is the azimuth? Azimuth that the sun has at that given moment when the observer notices the sun sitting exactly in the horizon at local midnight, then azimuth must be null because a circumpolar object is at its lowest point in the sky, which sits due north. And for question number D, of course, shortest known shadow would mean the noon must be at noon, sun must be as close to zenith. In fact, exactly at zenith, which means it must be exactly 90 degrees. So it basically gave the same answer as this question number B, because these are just the two ways to describe the same thing, one via shadows and another via altitude. So that that is it for today. I will see about this one, about some exceptions for modular sine and how to use them for different hemispheres into another video. I will make it. Up to then, bye bye, have a good day.